All right, we are live on time. How's it going, guys? Welcome to the stream. As always, I'm a one-man shop, so I'm gonna need you to tell me if the audio is okay. Just drop that in the chat. I've been playing around a lot with my Spotify setup because I've been listening back, and sometimes it's like really loud. Oh, hi. All right, I sound fine. Fantastic. Cool. So today, as you've probably seen on Discord or Twitter or Facebook or however you found me, we're going to be looking at Unity's new C# job system, which is really exciting. I've been watching that for a while. I did not get invited to the beta program, although I did sign up a couple times. But it's okay, because now in the new 2018 beta version of Unity, they've exposed some of the classes. I think they've exposed most of the classes. What they have not exposed is the new entity component system, which we had a discussion about this earlier on Discord, about whether or not the ECS or the entity component system and the new C# job system are really the same thing, or if they're separate. I'm leaning towards they're separate, but we can talk about that when we get into the code. So you may have noticed there was no video this week. Hey, thanks for the follow, Agnahajo, the hard one. There was no video this week. I was actually out of town this weekend. My wife ran a half marathon in Disney, so I was there, busy. But I've been working on a new video. In fact, what we're doing today... Hey, thanks for the sub, Drain THD, man. Really appreciate that. So what we're doing today is kind of prep work for my next video, because I'm hoping that next week I'll be able to come out with a video on the C# job system. And basically what I'm going to be doing is taking existing code, and we're going to optimize it so that it uses the C# job system and it runs a little bit better. So I haven't really spent a lot of time looking at the profiler. I'm not really like crazy. I mean, I don't spend a lot of time optimizing. I mean, if you've watched my videos on YouTube, you know that my niche is design patterns and writing clean code. So optimization really isn't my wheelhouse, but I'm really excited about this new job system, and it's something that I've been exploring. So I'm going to be looking at the profiler, or we're going to be looking at the profiler together, and hopefully learning a little bit about how that all looks. And yeah, we'll optimize this code. So I'd love to show you the ocean simulator, but my overlays are currently taking forever to load. Oh, there it is. Let's switch on over to my screen and see what this looks like. All right. Ruby Nova says, shout out to you using time.delta time for time sensitive work. Hey, thanks, man. Appreciate that. All right, so this is what we're going to be optimizing. Right now, this is a plane that's been generated using mesh generation in code. I'll show you all that. And basically, it's at the maximum amount of vertexes that you can have in a single plane, which is like 65,000. If anyone wants to Google that, here, let's Google that together. Unity 3D max vertices mesh. Yeah, so the vertex limit is 65,534. So as you can see, it's not running that poorly. If I can open up the profile here, I'm getting like 30 frames per second, which is pretty bad, actually. We want to optimize this, and eventually, if we were going to create some sort of game like, oh, what's that pirate game that just came out? It's got like beautiful ocean effects. If we're going to create a game like that, I'm going to need to add more meshes to the scene. And the more meshes that I add, the harder this is going to be to render and to keep the frame rate up. So the truth be told, I don't actually know if this is going to work. I think that it is, but I did another example with myself where I was visualizing audio using cube transforms, which I'll show you guys later. That's kind of like a bonus round. But I kind of jumped the gun here, and I really wanted to see if I could optimize this and make this run a little bit more efficiently. Hey, Bell Evan, man. Welcome to the stream, buddy. Good to see you. Oh, yeah, and I do mean Sea of Thieves, Ruby. Sea of Thieves has some great-looking oceans, and I wanted to see if I could recreate something similar. So let's take a look at the simulation, what we've got here. So if we look at the, let me make this a little bit bigger. Look at the simulation script in the editor window. You'll see that it has a mesh filter. This is the mesh filter that we create the mesh on. The grid size, so I have this 255 by 255, and the cell size, and that would be, I only have it 1 world unit per grid, per cell. Now we have this other thing called wave settings, which is a list. Basically, and I'll show you in the code, each one of these wave settings applies additively Perlin noise to our mesh here. So at the top end of the spectrum, let me just actually reset this. We'll set this to a single. So now we have a flat plane. Okay, flat plane, right? I'm going to apply some Perlin noise. So we'll just do it at a scale of 0.01. Actually, that's too small. Oh, we have to set the height too. So we can set the height of the Perlin noise, the height that this Perlin noise is going to affect the actual mesh. So we'll set it to, just to like really over exaggerate and see how big this is. We'll make it 10. Trongle says Sea of Thieves C isn't just a shader. You know what? It probably is a shader, but I really wanted to challenge myself and see if we can deform a mesh in an optimized fashion. All right, so now we have the height, the scale of the Perlin noise. You'll be able to see now how that actually affects. 0.01 is kind of like these large, these very, I don't know, wide humps in the mesh. As we start going up to 0.05, you can see how they get tighter, and 0.1 they're real close together. So there's that. So we'll make some big waves at first. Call that 0.01 and put the height of like 15. And then we can set the speed that they move. So 1's pretty fast. We can set that to like maybe 0.1. Okay. And now, all right, so additively I want to add another layer because, you know, oceans are very dynamic, and so we're going to add another layer here. And let's make these kind of smaller. Oh, not that small. That's ridiculous. Let's go 0.5. It's probably a little 2, 0.4, 0.3, 0.02. And then I'm going to make these actually a little bit smaller. So bring these down to 5. Just giving you an idea of how this looks. And we can actually change the speed of these. Maybe make them 0.5. So they're a little bit faster. Probably a little too fast. And lastly, we'll just add some texture to this. We'll call this 0.5. This is probably a little too much. We'll lower the height of these to like 0.5. And then now I'll give this a negative speed. And we'll move the opposite direction, maybe a little bit faster. You kind of get the idea. I mean, this is something that I'd like to hand off to a designer and let them figure out what looks nice. So let's take a look at the code. Oh, and also we can see profiling this. At most, this takes about 45 milliseconds per frame. And if you can see this, I know it's kind of small. The update on my script is what's taking the most time here. And you know what? I wonder if we could see this spike every time I added a wave setting. Probably will, because you'll see that it's a for loop. If I add 5 of these things, now it's gonna look at that. So it's gonna have to loop through each of these settings every single time I add more. Yeah, look at that. That's getting really bad. So now each frame is taking what? 80 milliseconds to render. So yeah, that's pretty bad. So I don't know. We're gonna need to optimize that, and hopefully it will be something we can optimize. And if not, then well, we'll just concede to the fact that meshes aren't meant to be deformed in this way. All right. So looking at the code, when we awake, I actually have this class called plane generator that generates a plane using grid size and cell size. So this isn't really that important. I'm not going to optimize this code today. But basically, when you call it generate, it creates a new mesh. It generates vertices, and it generates triangles. I do plan on putting this code. So anyway, what I was saying here is that I'm going to make this code available to my patrons. Also, if you guys don't mind letting me know if this is too small, the text, I'll blow it up as obviously as much as we need it to. I think I'll leave it about right there. That looks pretty solid. But let me know if you need to go to be a little bit bigger. Okay, so anyway, I'm gonna make this code available to my patrons, so you'll get access to that. Like I was saying, in the awake method, all I do is I generate a plane, and then really all the simulation does is it adds Perlin noise to the vertices of the plane, re-adds those vertices to the mesh, rather, and then it recalculates the normals. So this is where I think we have a bottleneck that hopefully I'll be able to remedy thanks to Unity's new C# job system. If we look at the add Perlin noise method, it takes a reference to the vertices, it takes our Perlin noise settings, and it takes a time, which allows us to actually move the ocean waves over time. And all it does is it generates an X and a Y coordinate that it can pass to Perlin noise, and then it multiplies that by the height and sets that to the Y value of the vertices. And what we're doing here is we're multiplying the X value and the Z value of the vertice, of any particular vertice, multiplying that by the scale that we want, plus time, times the speed, which are all inside the Perlin noise settings, which is just a serializable class. So pretty simple, but this is where we're going to need to add to a job. So is anyone unfamiliar with Unity C# jobs? I could go through a simple example, maybe pop open a new scene. Let's do that. So I'm going to save the scene, create a new one, take a look at what is entailed with these jobs. All right, what can I call this? Job runner? No, I'm gonna call it program. Whenever I can't think of a name for something, this is the entry point of this program that I'm gonna show you. So I'm gonna call this program. Let me add it to a game object. Program, all right. Set the transform because I'm anal, and we'll open this up in Visual Studio. All right. All right. So one very important thing about the whole C# job system is that Unity, or the people who created it, are very concerned about your memory footprint. So they basically use structs, because structs in memory are placed one after another, whereas classes, when you create a new object, C# object, in memory it just kind of gets randomly placed in memory, and that's random access, which takes a lot longer. So the main thing that you need to do when creating a job is you have to create a struct that implements, let's call this my job, the interface. Oh man, my stream is going down. Is it? I see it loading. Are we good? Is everyone good on the stream? See, I saw in the corner of my eye a little loading. Anyway, so you need to all right, good. Hey Ruby, I noticed that the delay is a lot less than it was when I was watching your stream the other day. Man, that delay was like 20 minutes, man. I'm glad that you guys can respond a lot quicker. All right, so when creating a job, you implement one of three classes right now, one of three interfaces. There's the iJob interface, which is your most basic. I'll just do that for you. My job, oops, 1. Okay, and then you're going to need to implement the execute method. Then the other option is to implement iJob parallel 4. iJob parallel 4 is actually for executing code in parallel, which we'll see. And it takes an index. We'll see how to use that index in a second. And then the last one is a specialty job, in my opinion, because it allows you to actually have access to transforms. Now, that's kind of important because in these jobs, you can't use C# classes. It'll throw an error. It won't allow you to do it. I keep seeing my video preview loading. Uh-oh. Now I see unstable in my stream health. Oh man, this sucks, dude. Bear with me, guys. I'm super sorry about this. I'm still kind of still got my training wheels on when it comes to streaming. I even like brought my laptop to stream so that this wouldn't be an issue. I'll keep an eye on it. How's the FPS, huh? It's pretty low, huh? Yeah, I can tell from the video preview. What's weird is that the CPU of my Streambox, yeah, I'm looking at the performance and the CPU usage is really high all of a sudden. So it looks like the FPS is better. Let me know. I can tell that the delay on my video preview is a lot greater now. I took a sip of my drink a while ago and I just saw it show up. Anyway, I'm gonna just try to press on. Someone let me know if we're good or not, or if it's still bad. Seems like it's okay. All right, I'm gonna try to press on. Hopefully we're good. So we have these three. Yeah, thanks, man. I appreciate it, Ruby. I really need someone to review these settings because they're trash, obviously. All right, so the type of job that I'm going to use in this example is the execute job, and I'm just going to use a really dumb example. Seems good. Everyone says it's good. Great. Awesome. Thanks, guys. Appreciate it. All right, so let's just create one simple job. And the job that they use in the examples in their videos is like this. It's like this array copy job. And I'm pausing because I'm trying to think of how I'm going to generate a giant array filled with data. So basically, there's a lot of things here, and I'm actually I'm teaching you guys and I'm learning at the same time because there's a lot to remember. Like I said, you can actually use types within jobs. So Unity has exposed their own types that are safe to be used in these jobs, and it's basically called, one of them is basically called native array. I haven't really explored the others. I've only ever explored the native array. Can you give me a 5-second recap of what you're teaching us? Sure, I totally can, John 5S. Basically, we're looking at the Unity C# job system. And basically, what it provides is an API that allows you to run code asynchronously and in parallel. So it utilizes multiple processors and allows you to optimize code that would otherwise take forever to run. And if you've ever done asynchronous programming or used different threads in Unity, you know that it's a real big pain in the butt. And it still is a pain in the butt with the job system, but it really does alleviate a lot of the issues. Or maybe it doesn't alleviate issues, but it makes it a lot easier for someone who doesn't have a lot of experience doing thread-safe programming or programming with multiple threads. It makes it a lot easier to do that. It abstracts a lot of what you need to know about multi-threaded programming. I personally have not done a lot of multi-threaded programming. So I know Ruby Nova has been doing a lot of async await stuff, but you know, he'll attest to how that has a lot of issues in Unity and how that has a lot of challenges. So I don't really have any buy-in with the new Unity C# job system yet, but a lot of what I'm doing here is just kind of testing it live with you guys, and that's kind of why I'm a little more choppy than I usually am when I'm teaching something, because usually when I'm teaching something it's because I know exactly what it is, like Zenject. I'm pretty familiar with that. This is something that I'm going to be learning during this stream. I played around with it and I do have a couple of demos that I've created, but this is going to be kind of new territory, trying to optimize the simulation. Yes, Ruby says it does not exist in Unity right now. That is correct. I'm using Unity 2018, and you can't even find any documentation from what I understand. They're going to add this to the documentation in later versions, probably when 2018 comes out of beta. Man, you just reminded me. It doesn't use a version of .NET in the stable Unity version that supports it. I never enabled the 4.6.NET package. Whatever, I'll do that later. All right, so back to this. When referencing objects in a job, so we have this array copy job, you need to use, from what I understand currently, you need to use their native types. They have a couple of different native types. I think they have like native hash map, which they use for their Boyd simulation. Let's see, native hash map. See, I know they have native list, native slice. So it actually kind of looks like not all of the native classes are available from what they demoed at Unite. But I know that native array is here, so I'm going to just add a public member variable to our job called source. Source. Okay, and then we're going to add another one called destination. Okay, and basically all this job is going to do is copy everything from the source into the destination. And you know what? Maybe I'll have another job that's called populate array job, which is also going to be a parallel for job because I want it to run in parallel. And this is just going to have a destination array. Okay. All right. So let's say, for the sake of testing out multiple values, I'm going to expose on the Unity editor a serialized field. And we'll call this count or array size. Now you imagine a huge array will take forever to populate and then copy to another array, like 1 million records or something. But we're going to see that with this job system, it's going to be much simpler or much faster. All right, so now we're going to need to allocate some arrays, some native arrays. I'm going to call this source, and we're going to create a new native array. And I've played around with this a lot, and it's going to be a native int array, and it takes two things. It takes a size. So basically, what's happening here is you're actually allocating in memory an array. So we're going to set it to the array size that whatever's. Oh no, rip. Nope. Oop. We have spike. We good? Frame rate's good? Okay. Alright. Thanks. It's like, if maybe like every 15 minutes, if we drop to 1 frame per second for like a minute, I guess we could survive, hopefully. Alright, so when you allocate a native array, you give it a size, and you actually give it, I guess, a period for how long it's allocated for. So you could say, okay, I want to allocate this temporarily, and I want to maybe allocate this just for the job. So I need to learn a little bit more about these. Like I said, there's not much documentation. In the Unite video on this subject, he talks about it. But I have been just saying I'm going to allocate for temp job, which in my mind is, actually, I'm going to actually allocate this for temp. In my mind, this just says I'm going to just allocate this temporarily for a brief split moment in time, and then it will be deallocated later. And you'll see that we actually do the deallocation. Ah, shoot. I see my stream health dropping again. I'll give it a second. I feel bad for those watching the VOD too. Sorry guys, I promise it gets better. I'm from the future. No, I'm from the past. And it gets better. Alright, seems like we're excellent again. I can't wait for you to look at my settings, Ruby. Alright, seems like we're good. Alright, so I'm going to allocate a source array, and I'm also going to allocate a destination array of ints. Again, array size, and we'll just call this temp, allocate it for a temp period, which I'm not really sure what that is. I wonder if I can actually control click in and see if there's any comments in the code itself. Okay, yeah, this is what shows up in the IntelliSense. Used to specify allocation type. Maybe in the constructor of the native array, it'll say a little something something. Yeah, nothing. It's just going to expose everything that's already on IntelliSense, so I'm not going to worry too much about looking at that. Are you actually the Doctor? What is that? Is it a Doctor Who reference? How we doing? I see another dip. I see another unstable in my stream health. Oh yeah, that's unstable. Okay, we're back to excellent. My God. Okay, so now we're gonna create our populate job. Populate array job. You know, I can never get into Doctor Who. I tried, but I don't know. Didn't really do it for me. I'll have to give it another shot. Oh, I see. Yeah, time travel. Timey-wimey. That's like the only reference of Doctor Who I actually know, and then the blue phone booth. Alright, so we have our populate array job, but now we actually need to give it its values. And this populate array job takes a destination array. Which is kind of misleading because the destination is going to be our source. So I'm going to call this array. Oof. Okay, so we'll set that populate array job dot array equals the source. We can use object initialization. I mean the object initializer. Thank you, Resharper. Gotta love it. And now that we have a job, all you have to do is call schedule. Now, the schedule method takes a couple of parameters. It takes an array length, so this is the total size. This is how basically how many times the job needs to run. So I'll call this array size. And it also needs a batch size. So you can actually, so let's say you were going to process 100 different elements, and you gave it a batch size of 10. Well, then that would cause the job to run 10 times. Excuse me. Or basically to thread itself 10 times. So in this case, why don't we make this a variable? We'll call this batch size. Okay. And basically what's going to happen here is that each index will be one. It's going to go from 0 to the array size, and all we're going to do is just say array dot index equal, I don't know, basically we're just populating it. I'll populate it with the number 1. Okay, do something fancy like random, but who cares? The fact is we're actually populating something, which is cool. Okay, so now once we have that, whenever you schedule a job, it returns a job handle. Oh, this is going to be a long name. Populate array job handle. Oh boy. And what you could do with the populate array job handle, or any handle, is you can call complete. When you call complete, you ensure that the job will be completed. And this is important for, excuse me, this is important when you have dependencies, which we'll look at right now. All right, since there's been so many breaks, basically I've got 2 jobs, populate array job, array copy job. Populate array job is going to use multiple threads to populate array with n number of elements, and the array copy job is going to copy those elements, or the elements from a source array, into a destination array. So we've already got the populate job created. We learned that the populate array job, when you schedule it, is going to return a handle on which we can call complete. And in a second, we're going to have to add a dependency. Last thing I want to do is I want to call dispose on the source native array. This deallocates. So when you're using the Unity C# job system, you have control over the allocations and the deallocations. And if you don't deallocate, it will throw a warning in your console, in your application. Okay, so I'm going to create a new job. We're going to create basically the array copy job. Okay, and we're also going to have to set those 2 values, which will be source. Again, source, no brainer. And we're going to set the destination to the destination. And we can allow Resharper to show us how to use an object initializer. Beautiful. And again, we're going to have an array copy job. Come on now. Copy job handler, which will be returned when I call array copy job dot schedule. Okay, so we're going to do array size and batch size, and now we're also going to have to, or we want to add a dependency. So we're going to depend on the populate array job handle. Oops. Yeah, so it takes a job handle. Okay, I actually thought I was going to take a job, but it actually makes sense that it would take a job handle. So if we schedule the array, I believe if you schedule the populate array job, you pass that handle into the array copy job handler, and that will cause, when we call array copy job handler dot complete, it will force the populate array job handle to finish first before it starts running the array copy job. And I don't think we even need to call the array job, the populate array job. I think by calling complete on the array copy job, the second one, it'll cause both of them to complete. And I'm also going to dispose the destination array. Stream health looks good so far. Everyone good? Everyone good? Looks okay to me. Got my fingers crossed. Alright, so this is very simple. This was supposed to be a very simple example. I'm going to copy from the destination, from the source to the destination. And that should be all there is to it. And when these are both done, when I call complete, what could I guess the profiler is really where we're going to see some magic, but I'm going to call debug.log, and I'm just going to output the the destination array dot last. Yes, I am live. Hey, thanks for the follow there. Even though my stream's going down a million times. All right, let's run this job. Okay. So now we have our program, and we're going to be able to see. We're going to see in the profiler how fast this actually runs. My cats are losing it. Chip! Oh my god. They are tearing up my blinds. Alright, we'll start with an array size, a modest array size of 1,000 elements. And we'll do a batch size of 10. We should be able to see... Oh, let me make it 100. Because I want to be able to see 10 jobs running in the profiler. Alright, we don't need the scene because all the magic happens down here. You can see in the profiler that we actually have a Unity job system section. See these worker threads here? Can I make these smaller? It doesn't appear that I can. These main threads and the render thread. Okay, those are important, so I can't make them any smaller. Alright, let's give this a run. And I'll be able to, hopefully, take a peek at these threads. Wow, look at that. Is that them right there? No. No, I think they would have been... Maybe I'll just run it once every frame. I think maybe that'll be easier to find. Something borked again? Is my audio off? We still have Visual Studio on the screen. Okay. Are we borked? We good? Let me know if we're good. You should be able to see Unity. I wonder if it's possible for... Does it feel like we're off here? As far as does it look like my desktop audio is behind what I'm actually saying? Let me know. Let me know. I think I'm so far zoomed out on this thing that, God, it was like 30 seconds worth. Here we go. Goodness gracious, look at that. Yeah, like I said, oh, here we go. I think this is, yeah, this is the beginning of the frame. I don't have a lot of experience with the actual profiler. Well, we can see that the job is running. It's logging out the last element. Trying to find it. I did this the other day. I'm trying to find it in the actual profiler where the jobs are running. This is idle. Huh. Should be here in this job. You know what? Maybe it's just so fast that it's too small. Let's make this array a little bit bigger. Maybe 10,000 elements at a batch size of 500. See what that does. It's going to run every frame. Cool. Audio is good, and I am in sync. Love it. All right, I'm trying to find these jobs. Here we go. Look at it. There we go. Okay. All right, so look at this. We got the array copy job and the populate job, and because they depend on one another, you can see that they run. The populate job runs before the array copy job, and look at this. The populate array job took 0.27 milliseconds, and the array copy job took 0.6 milliseconds for 10,000 elements. Some of them took a little bit longer than others. Beautiful, I love it. All right, what if we can jack this up? Well, it's still running. I guess I could just add more. Let's add this. Let's set it to 1,000,000 records. See what happens there. Okay, now something's happened here. All right, we can see that the array job's taking a little bit longer to run. 1,000,000 records. I wonder if I increase the batch size. I wonder if this is killing my CPU. 1,000,000 records seems to be a lot, so maybe I'll not do 1,000,000 records. Let's do 100,000 records at a batch size of 1,000. See what happens there. I'm trying to learn this profiler, what's happening here. Okay, that's much better. Stop it on this frame. Here we can see our jobs, array copy job. This is an interesting thing too, because one of the points that they make, selling points for this that they make in the Unite presentations, is that this is good for battery life of mobile phones, because as we can see here, when these jobs aren't running, this section of the frame is idle, so the CPU is idle. So that was one of the selling points, that if you can get the job done quicker, then your CPU will be idle longer. So that's pretty cool. Let me increase the batch size. I'm not really sure how large I can make the batch size, but I guess I'd want to make it smaller, right? Because the more batches that are running in tangent, the faster, right? Not really sure, but I mean, it looks like a little bit of an improvement. Oh yeah, I would say definitely an improvement there. You know, more are running. What if I lower it to 50? Because if you have a large batch, it's obviously going to process way more. All right, I think it's time to actually get to our ocean simulator. So if anyone has any questions, feel free to let me know. I'm going to save this scene. Remember, all this code will be available to the patrons. Head on over to my Patreon. It's in the panels, and you get access to all the code in my videos and my streams, which I'm getting way better about posting. All right, so I'll save this as job example. All right, so we're going to go back to our simulation scene, take a look at our ocean for those who maybe have missed it. Seems like the stream health is much better now. Probably just jinxed it though. I think because I said that, I think it's going to crash. So prepare yourselves. Okay, back to the simulation scene we go. In case you forgot what that looked like, let's press play and see our beautiful little ocean. Oh wow, amazing. So now we need to figure out a way to find the bottleneck and isolate the bottleneck. So I'm opening up the profiler, see if I can understand this a little bit better. Because I made it smaller, it seemed to... No, I guess not. Okay. Cool. And before flaming train wreck occurs again. Yeah, it's going to happen. I'm going to stop it on a frame here, and we can see that the update method in my simulation, this blue line right here, it takes 28.84 milliseconds to process. No good. That's too slow. So I'm going to see if we can leverage the job system to process this Perlin noise method a little bit better. So one of the things that I might need to do is change this Perlin noise setting class to a struct. And the reason why is I'm going to need access to these settings in the job. But let's not get ahead of ourselves. I'm going to I'll go ahead and just create this struct. Call this additive Perlin noise job. How do you like that? Because it's adding Perlin noise to the vertexes that it gets. It's going to be a I job parallel 4. Just off the top of my head, I imagine it's going to have a native array. Native array of ints. Oh, no. Vector 3s. Which, okay, this is kind of strange. I tested this out last night, and evidently this is legal. Even though you're supposed to not be able to, like, add an object like a vector 3. Is that a struct? Oh yeah, vector 3s are a struct. I should have known that. Cool. So I'm going to drop this into another file. Additive Perlin noise job. Trying to be clean coder here. Yeah, no, Ruby. I thought that vector 3s were classes, and you're not allowed to. You're not allowed to have classes inside of jobs. Speaking of shameless plugs, Ruby, you didn't remind me. I'm supposed to show off Ruby's super cool Unity docs bot in our Discord server. It's a Discord bot, but I'll show you in a bit. Stay tuned. Okay, so just to show you, if I were to add the Perlin noise settings here, this would not be valid, and it would not work. So I'm going to, in our update method, create the job, additive Perlin noise job. Okay. Oops, gotta add new. First day. If I were to schedule this job, for now I'm just gonna put 10 and 10, and do all the things you have to do. Complete. You call complete on the handler because you want to make sure that it completes for every frame. Job handle dot complete, whatever. Oh, excuse me. That Unity is going to throw some issues in the console. It's going to complain about it. Okay. So it says invalid operation exception. Additive Perlin noise job settings is not a value type. Job structs may not contain any reference types. That's a better way to word what I was trying to express to you guys. You can't have reference types. So a struct is a value type, which means we're going to need to transform or refactor our Perlin noise settings to be a struct. I don't know that you can do that easily with resharper, so I'm just going to make this a struct. I don't think it's that obtrusive. Cannot have instance. Oh, right. I was presetting the values. I don't need to do that. Okay, pretty solid. And everything else should be pretty good. Good to go. Let me make sure that we're all right on the simulation front. As this builds, I'm not really sure if it's going to wipe out my settings. It did not. Wow, did it? Let's see here. All right, I'm going to press play again, see if we get those errors. We did. Okay. Okay, yeah, you actually have to assign. See how, so it's very, this API is very helpful, right? Because, you know, there's so many issues you could run into when you do multi-threading programming. And one of the things that they tout about this is that it's very verbose. It will tell you when you're doing something that's wrong or unsafe. And basically, I've created this job and I never set the vertices or settings values. So it's complaining about that. Rightfully so. And the last thing we need to add is a time variable. Basically, I'm copying this Perlin noise method that we have here. Okay. Okay. Before I go and start adding vertices, I'm going to just add the logic to this job. So if we look at this logic, I can just copy and paste it. Should be good to go. Of course, I'm going to have to fix some things. Let me drop this over in the main screen to make it a little easier to read. Right, so this is going to be... Let me make this a little bit easier. I'm going to break some conventions so I can do some easy refactoring. Pro tip. And I'm going to call this I. Okay. Okay, I know this is the problem I had last night when I was playing around with this code. You can't set this, but it's okay. For now, I'm going to ignore that. Let's continue doing our refactoring. Hit F6. Control F6? Which one was it? Okay, Control F6, or Shift F6. Shift F6 is going to allow us in ReSharper to rename this to vertices with a capital V. In fact, I think I could just Alt Enter and it's ReSharper is going to tell me to rename this to settings with a capital S. Just code conventions that I follow. You don't have to follow this. Time for public member variables, I do Pascal case, which is basically camel case with the first letter capitalized. Hey, Kark and the Sad, thank you for the follow, man. Okay, so it says you cannot modify the return value of a native array because it is not a variable. Cannot modify struct member when access struct is not classified as a variable. I'm not really sure what that means. Do we get some IntelliSense? Interesting. Really? That's interesting. So how would I set this back? Oops. Huh. Okay. That's a first for me. Seems like something more like C# related, some advanced C#. So what I'm going to do is I'm going to just select the entire vertices with the index there, and I'm going to hit Control Alt V to create a variable out of it. I'm going to replace all three occurrences. Let's call it vector3. Oops, I undid too far. Let me rename time again. Oh, and I'm also going to rename this I to index. Just like to be a little more explicit. And what do we call this vector3? I think I'm going to call this vertex. That seems to be a little more, yeah, more readable. Okay, so this seems like it's going to be pretty easy. Knock on wood. I hope I'm not missing something. So let's go back to our simulation. We're going to replace this logic. Yeah. So we're going to have to run a job for each one of these. Wonder if I could just stick all this code in here. So as a first pass, I'm just going to do it all in here. Yeah. All right. So the job handle. it needs a size. It needs to know how many elements it's going to be processing. So let's call this vertices.length. And the batch size, for now, I'm going to set this to 100, or do 500. And I'm going to comment out this code for now. Or just to be really clean, look at this. I'm going to hit Control-Alt-M. It's going to pump all this into a method. I'm going to call this old Perlin noise. And I'm going to get rid of it. So this will be here in case we need it. And now we actually need to add the values, right? So job.settings is going to need to contain the settings. And job.time is going to need the time. We also need to set job.vertices. Now this needs to be a native array, so I'm going to put it up here. Vertice, I'll call this vertex native array for now until I come up with a better name. So new native array. Okay, and it's going to take a vector 3. This size will be vertices.length, and we're going to allocate it for temp job. I need to learn more about what those allocations mean. And then we can just set the vertices to our new vertex native array. And I'm going to use object initialization by mousing over new, Alt-Enter, and select use object initialization. Great. Thank you, ReSharper. I wish they would sponsor these, because I always tout how great ReSharper is. All right, so we call jobHandle.complete. That completes the job, and then we need to deallocate the vertex native array. Remember, with the C# job system, you are in charge of allocation and deallocation, but it makes it a lot easier to do. So I think this is all we really need to do to get this going. What's up, Bell Evan? What's the Need me to explain something a little deeper? Alright, so I'm running this, and just to see if it worked, and it doesn't look very promising here. What happened? Let's look at the profiler. Well, we can see, pause it, seems to have a better frame rate than it did before. When vertice array is copied, oh, yep, I totally missed that. Thank you for calling that out, man. I never copied the array over, right? I just allocated the array, but I didn't actually populate it. So how would we do something like that? Copy from vertices. Interesting. Okay, yeah, so I think we lose the ref here, the reference, right? So I think at the end of this, I'm going to need to set vertices equal to vertex native array. Oh, you know what I'm going to have to do? Before I dispose of it, I'm going to have to call native array dot copy to vertices. Good call, man. I missed that, which is why it didn't work. So just to step the code one by one, we allocate a new native array of vector 3s for the vertices.length. That's how large it's going to be, how big of a memory chunk we're going to allocate. We allocate it for a temporary period of time. Then we copy into vertex native array our vertices, create a new job, schedule that job, call complete to ensure that it completes immediately, and then we copy the vertices from vertex native array to our vertices array, and then we dispose vertex native array. So let's see if that actually does anything. Press play. See that we don't have any deformation here. I do see that the job is running. And pretty efficiently, too. I mean, look how long it takes. What were we at earlier? Like 23 milliseconds? Now it's at 2 milliseconds? That's pretty good. Though it's still not working, so... Gotta figure out what the deal is. Did I even add logic to this thing? I did, right? So vertices... Do I need to... I think I need to set this back. I need to basically grab the vertex from the vertice, manipulate it. There might be a better way to do this. And then I need to put it back into the same index. That might be what we're missing here. If not, I'll do a little bit of debugging. Okay. All right. Wow, look at that. So each frame is still taking a little bit of time. You know what I'd like to do, actually? I think I want to help our debug here. I'm gonna add a new field. We'll call this enable job. All right, so inside of this, if enable job, we'll do our fancy job version. Otherwise, we'll just do the old one. Okay. That way we could take a look and see what's happening here. And like I said in the beginning, it could be that there just is no way to optimize mesh deformation. We'll see. All right. What's it complaining about? What's the problem, buddy? Oh, I guess when I refactored this method out, I forgot to, or it didn't take the reference. Oh, that'll do it. Okay. Let that compile. Our enable job is unchecked, so at first it's going to use our old way of doing things. What is this? Oh, well, whatever. All right. So, it looks like enabling the job made it worse. Enable job, it does, yeah, it uses the job. Cool. Memes, as Ruby Nova would say. Let's stop on a frame here. As we can see, there are no jobs running. We see that the simulation.update takes 23 milliseconds to run. Now I'm going to hit enable job. We see a definite spike. Memes. I did warn that this probably wouldn't, I mean, not that this probably wouldn't work, that I just didn't know if this would work. I mean, maybe there's something heavier going on in the background with Unity that you just cannot avoid. So, yeah, we see that the jobs are running, but the simulation's update method still takes 32 milliseconds. The longest running process here is process commands, GFX process commands. It's the render thread. The recalculate normals doesn't take that long, 4.2 milliseconds. So what's happening here in between all of these? What's happening inside of this that's taking so long? Does some okay, so it does some allocations. The jobs themselves don't take that long. Are you double-sided rendering something? Let's see. I don't think so. No? Got culling on. Cool, well. Let's look at memory. I never really took a look at that, the difference. So we'll disable the job. See how the memory looks. Well, guys, unless I'm mistaken, it looks like the job system does nothing for mesh allocations. Kind of sucks, though. I thought it would do something. What are these yellow spikes? It's VSync. Wait for target FPS. It's running so much better that it has to wait for the target FPS. Shucks, man. Well, I think I have enough time to show you. I have another pretty cool example that I can show you guys of where I know for a fact that it actually does show improvement. Maybe if I mess with the batch size. I doubt it though, because look at this. When you actually look at the workers, you can see how fast they run. I mean, look at this thing. There's even idle time between each of these jobs. So there's something else about how we add these vertices. Maybe if I just pass in a reference to the actual mesh filter vertices. Let me do a Control-Alt-N that inlines. It's supposed to inline. Yeah, inline variable. That's not gonna let me, huh? I don't think I can actually. Yeah, I can't. I can't reference those. Well, shoot. That kind of sucks. It's cool, though. Let's download a song. I need a song. Because I'm going to show you another way that the job system actually does benefit. Okay, I'm going to look at Argo Fox. Because he's got good music that I like, and it's all non-copyrighted, and I hope... Oh, you can't even hear the music anyway. Ads, go away. Come on. Alright, so I'm going to download the song. Basically what's going to happen is I'm going to visualize audio frequencies using the job system. And basically we're just going to create a whole bunch of cubes and affect their Y position based on the audio frequencies. So let's do that. I'm going to download this baby. I'll keep checking back. I'm going to create a new scene. Gotta push through these things, man, you know? New scene. Gonna save this guy. Save it as audio visualizer. Alright, drop that in my scenes folder. Again, plug for Patreon. If you're a patron, after the stream, I'm going to put all of this code on my Patreon. In fact, I've made it a goal of mine to put this up tonight. So that's the goal. Hopefully, if you're a patron tonight, you will have access to all of this code in all of its glory. All right, so I'm gonna create a new. Oops. Oh, I actually did want to do that. My bad. I'm gonna create a new object. Call this audio visualizer. Excuse me. We're gonna add a script. Call this. Shameless plugs, baby. You know all about that, Ruby. Audio visualizer. Let's open this baby up in Visual Studio. Okay. I wish I could reference the code. I wonder if I could. Oh no, I can't, because my whole stream's gonna blow up. So I have to do this just to figure this out. I did this the other day. It was super cool. I did this right before my trip to Orlando, and now all of this is gone from my memory. All right, I do remember having to add a field, a serialized field for the audio clip. Right? We need to set the audio clip that we want to visualize. So, audio clip. Audio clip. Beautiful. Stream looks good so far. Excellent. Until it's not. Let me just really quickly in update. There's some class. It's a static method. Audio. Hey. Oh, that's mine. I'm like, audio visualizer? Is that. Maybe it's audio source. No, that's not it. I'm gonna have to go to the documentation. Oh my gosh, the documentation. Dude, time for a plug, Ruby. Hope you're sitting down, buddy, because I'm about to plug your beautiful bot. Alright, I'm gonna drop this in the... Is it online? Good, it's online. I'm gonna drop this in the live stream channel. Okay, multiple shameless plugs. Shameless plug number 1. Join us on Discord if you haven't already. We have been growing. I was just sharing the statistics with everyone. And this channel has been growing, and we're like seriously active. I'm insane. You guys are always on here. It's awesome. I love, like, it's become part of my morning routine to hop on here and figure and see what questions are being asked, and beginner questions or Zenject or UniRX. And like, seriously, the first thing I do when I get to work is like, God, I hope none of my coworkers or bosses are watching. They're probably not. The first thing I do, and don't clip this, the first thing I do is I grab a cup of joe and I start answering questions. It's a good way to exercise, get me started, get me fresh for the day, and help you guys out. So this is cool. That was shameless plug number 2. Shameless plug number... No, that was number 1. Number 2. If you're a patron, you get access to this lovely patron channel. And you also have access to the Unity bot here. That's cool. Last shameless plug is Unity Docs. Now, this is an amazing bot created by the one and only Ruby Nova, and you could call things like mono behavior. Actually, let's call help. Unity Docs help. This displays all the available commands. As we can see, you can call docs, the name, and the optional version, which is the version of Unity. F for what? F for which statement? Oh, look, you can even list out the versions. I didn't know you could do that. Ooh, so now currently supported versions are 2017.1 and 2017.3. I assume it just defaults to the latest stable version, which is 2017.3. And let's see how smart this is. I know I can type something like mono behavior, right? Really, this is great because it's a nice way to drop a link to the Unity docs very quickly, and also kind of get a little tidbit on what you're looking up. Let me look up audio. I don't know what it would return. So look at that. Probably meant. Man, look at this. It's smart. Man, Ruby, awesome. So creates an audio clip playable. I'm just gonna go straight to the documentation here because I'm not even sure what this thing is called. All right, audio. What if I just do a search on audio? I'm trying to find the static function that returns. What if it's on the clip? Oh, I think it's on audio clip. No. We already looked at audio source, I think. What other audio? Is it audio listener? Maybe it's on the actual audio clip itself. No, I don't think so. Get data. No. What do we have available? I'm trying to find the class that gives you access to the actual audio, like the audio frequencies as the song is playing. And I think I'm going to have to just reference... It wouldn't be mixer, it wouldn't be player. I'm going to reference the actual code that I already wrote. So if the stream dies, memes, and at least I'll get a bit from Bell Evan, right? Love you, Bale Evan. You're the best. Okay, where did I put this code anyway? Who knows? Oh, I think I know where I put it. I put it on the desktop of the potato that's streaming, that's currently streaming this. We good? Are we still alive? Oh no. Oh, you found it? Oh, drop it in Unity docs. Drop it on on the patron channel. Or did you already put it on general? Oh, audio clip.frequency. Is that it? It doesn't look right though. Let me see. Okay, I'm gonna look at it. While simultaneously. Okay. Potentially. Okay, you're still alive. Good. Shoot, man. Where did I put that? I think I have another. I think I know where it is. Okay, so. Assets. I'm on the potato now. Yes. It's get spectrum data. Get spectrum data is what I'm looking for. Oh, friggin' A. There goes the stream. My bad. I shouldn't have. That sucks. So we're back in audio clip, and it was the audio source. But the problem was I actually need an instance of the audio source. That is where we went wrong. So let's do that. So here is where we grab the spectrum data. Oh man. Oh, audio clip. Whew. Audio source.get spectrum data. And this will return a list of all the samples, I believe. But it wasn't spectrum data. I think it was another one. Get... Because one of them was deprecated. I know there was output data and spectrum data. And yeah, basically you need an array that it'll populate. I'm just referencing my code. Hopefully it won't blow up my freaking stream. I think every time I use this computer, that's when it goes down. That's when it goes down in the DMs. I'm just referencing my code because that is going to make my life a lot easier. So, excellent so far. Okay. Alright, I don't have to think now. Okay, so now basically I'm going to create... Are my cats running around? I hear them. Alright, I'm going to create a float array. We'll call this spectrum data. Spectrum data equals a new float. I think the sample size is limited. I think you only get like 8,000 from get spectrum data. But I'm going to make this something we can edit, so we'll make this an int. Spec data size? Spectrum size. Yeah. Alright. If you've watched the stream before, you know that I care too much about the names of my variables. Alright, this can be a var. Alright, we'll pass the spectrum data here. And the channel will be 0, since we're going to have the one channel. And you can actually... There's this FFT window that I'm not really sure what that is, but it's something in audio. Like some algorithm or something. I looked it up on Wikipedia and I was like, oh, my brain's going to blow up. Alright, so we get the spectrum data. There you go. That's funny because before I used audio listener. This was the static class. There it was. But whatever, I'm going to use audio source. I like that better. Okay. We also have to play this too, right? So starts. Here we're just going to use our audio source. What am I doing? I don't even need the clip. Because we can set that on the source, right? So I'm going to do audio source.play. Flat. All right. Cool. Let me really quickly set that up in the inspector. I want to make sure this all makes sense. All right, so we're going to add the audio visualizer. And the spectrum size, we'll say 256, like I said. And I'm going to add the audio source, which we can use this song, Starry Night. I'm pretty sure I've used this in like half of my videos on YouTube. Shameless plug, go look at YouTube, my YouTube account. Good videos on there if you like this content here. Alright, so we're going to set the audio source. That should be all we really need to do. I'm going to press play. I can hear it, but you can't. I just want to make sure I can hear it. Yeah, I can hear it. Oh, wait, cool. I've never actually used that song. I thought I did. So we're going to, basically on every update, we're going to create a new float. We're going to eventually allocate this. And then basically we have to loop through the spectrum data that we get back. Oops, spectrum data. Length. Oh, I guess I could use size. Yeah, I'll use that. Set this to a var. And, right, so let me remind myself, what is spectrum data? It's a series of floats. Right. So I'm going to need some game objects, some cubes. So I remember I had this method called generate cubes. Let me implement that. Right, okay, now I remember. So now I'm going to loop through, again, the spectrum size. Yep. And I'm going to create a cube using the primitive GameObject.create primitive cube type. And I'm just going to set the position to a new vector at 0. Actually, it was I00. And that should be it. You can use the graphics API to draw cubes without game objects. What? Do tell. You tell me that, but I'm going to move forward. Let me see what that looks like. Now, this is not a practical example. This is just an example to show how the profiler... Sorry, the music's playing in my ear. Alright, this is just to show off the profiler, how it's my code's going to be optimized and it's going to run a lot more efficiently. Hopefully. Yeah, I know that with the graphics API, you can even use like debug.drawLine, right? Okay, so we've created our cubes. Should probably store them somewhere, right? I'm not going to serialize this one. I don't want anyone to know about this one. Alright, gonna drop these babies into a list of game objects. Call this cubes. Oh, for God. Just cut out, huh? Oh, look, everyone be happy. The kitty's here. Listen, Boots, can you fix the stream, please? Listen, I need you to go over there, put in the best settings, okay? Make them extremely optimized. This is a potato that we are streaming on. Oh my God, look at this thing. Look at this friggin' thing. What is this? Huh? Alright. Fix it, okay? Go. Fix it. No. Fix it! Okay. I'm losing it. Yeah, he's pissed. He's like, what are you doing, bro? I don't know what I'm doing, cat. I don't. Okay. We're back. So we've created cubes. The old-fashioned way with create primitive. Do we do this in the start method? A little slow. Don't care. It's fine. This is just for the example. We know. So now let's see if we can visualize this using our cubes. Oh, I have to add our cubes to the cube array or list. So we're going to set the cubes variable to a new list of cubes, and I am going to add each cube to the cube array or list. Okay. Now we should be able to loop these cubes and set the position. Dot transform dot position equals new vector 3. You know, we're not going to overthink this here. We're going to get the spectrum data at I and put it at 0, 0. Oh, I'm sorry. Yeah. Yeah, like that. Yeah. So we're going to basically be controlling the vertical position. Oh my gosh, if this stream friggin' dies. Oh. I'm back to say goodbye, guys. I think the fates have spoken. Look, both of my cats are in the shot. Can someone clip this? Maybe this is gonna be the thumbnail. See, I got one cat here. And I got one cat here who's disgusted. Hey, say something, buddy. They're both disgusted in the stream setup. Well, guys, I'm sorry, but I think this is where I'm gonna have to cut it off. This is already gonna be hell in a handbasket to edit this VOD. But this code will be on Patreon, as I said, by the end of the night. And this, well, you could just consider this audio visualizer as a bonus example. I will finish it and put it up. And yeah, next stream, I don't know when my next stream is. I mean, it's next week, but I'm not sure what day it is. And I don't, if you look at my panels, I don't think I have a stream date past the next one. So I'm gonna need to work that out. But so stay tuned for that. Yeah, so the next stream is on the, whoa, I have it on the 15th. Maybe I don't stream next week. Yeah, it looks like my next stream is not next week, but the following Thursday. I'm going to have to confirm there and get back to you guys. But hey, join us on Discord. Follow me on Twitter and Facebook. And for Unity tutorials like this, follow me on YouTube. I had a fun time despite these nonsense crashes. But I'm going to have Ruby Nova take a look at it, and hopefully we'll get it all sorted out. Let me think. Is there anything else? I better think quick because this thing is going to die before I could even do an outro. I think that's it. Thank you, guys. Thank you to my new sub and my new followers, and Ruby Nova and JMC for being my mods, Bale Evan for being a faithful patron and sub. Oh yeah, that's right. Ruby wants me to plug him. You can head on over to Ruby, and if he was streaming now, I would probably do a raid. But Ruby Nova SC2, that's his username there. You can follow him. He will be streaming. He does a dev talk, a game dev talk show podcast with his friend Kellen, which on YouTube he is, I mean not on YouTube, on Twitch he is Pothead Pete. Follow them, check them out. They're cool guys. Got a fun stream, and stay tuned for my next stream and for this VOD. So catch you guys later, and I hope I'll see you in chat. I'm gonna go grab dinner, but I'll probably be back on chat in about an hour. We'll hang out. Yes, go on Discord. It's linked below. Alright guys, I'll see you later. Have a good night.